We're going to move on to our next session, Mobility and Robotic Arm Enabling Deliveries, starting off with Caleb Fassett on exploring the neotectonics of the moon, the young, rocky Dorsa Aldrovandi Wrinkle Ridge northwest of Taurus-Littrow. Take it away, Caleb.
Awesome, thanks. Just a quick sound check. Can you hear me? Okay, great. Next slide, please. So when I saw the call for this particular landing site workshop, my mind instantly went to think about basin rocks. But I realized that the report that Erica Jowan talked about earlier did a nice job describing the science case for looking at the age of basins on the moon. And so I looked at what landing sites were captured in that document, and I tried to pick out something I thought was sort of not fully captured yet. And one of the things that I'm scientifically very interested in are some of the landforms that Dorsa Aldrovandi is an example of, which are these young, big thrust faults on the moon. And Tom Waters, who's a co-author on this particular talk, will give a better introduction to this next, probably, because he's one of the discoverers here of this phenomena. But I kind of come about it backwards, which is I really like these landforms partly because they give really good exposures of fresh, large rocks on the surface. So this paper here, the geology paper in the center here by Valentinus and Schultz, showed this really nicely, and also the French et al. Paper. There are lots of rocks on some of these big wrinkle ridges. That's partly how we know they're young. And so we could go and explore them both in terms of the wrinkle ridges themselves, but also the geology of the areas they're cutting. So if you go to the next slide, please. So you all have heard already that the advancing science of the moon called out seismicity and recent tectonism as one of these goals. And so we could address that by visiting one of these locations. That's kind of the low-hanging fruit. And then also looking at the character of the surface and subsurface of these locations by actually transecting across them with mobility, I think is important. Perhaps the thing that I'm bringing to the equation here is that you can also get these landforms as a way of looking at the fresh materials, the materials that are exposed in the last 100 million years or more. The actual cause, the lunar evolution causes of these tectonic features remain kind of unknown. So we don't know whether it's subsidence due to Mare loading or orbital recession or tides or global contraction or almost any mechanism you could come up with geophysically for why these landforms are young. But I think exploring them more would help address that question, and also figuring out whether they're the current source of the young shallow moonquakes. Next slide, please. So this is a picture quickly of Dorsa Aldrovandi. It runs basically for a few hundred kilometers on the eastern flank of Serenitatis. And the Apollo 17 landing site is labeled in the pink image there in the lower part of the image. And so if you started at the top and transected down this landform, you could eventually get down to Taurus-Littrow and actually revisit that site if you had enough mobility. There's a couple of things about this image I wanted to call your attention to. One is that the diviner rock abundances are shown here in the middle, and almost all the places that are anomalies in rock abundance on the moon are young, fresh craters, and these wrinkle ridges are the exception. So they give really amazing exposures of rock fields across a lot of the terrain of eastern Serenitatis here, including parts of the highlands to the northeast. As well, and so you could look at highlands and possibly Mare rocks, and some of the rocks exposed in young cut craters. If you go to the next slide quickly, it shows a couple more of these just very large rock fields that you would traverse through. I'm hoping you have a lot of mobility and capability with your rover to navigate through rough terrain. And with the cameras and remote sensing instruments, you could, in principle, look at the actual relationships between grains, the textures of rocks, some of the things that are harder to do when you only have regolith exposures. And so, we don't have road cuts on the moon. We don't have, nice river cuts, but we do have these places where there are big rocks brought to the surface recently for us to look at. And the slide, the image to the lower right there shows all the areas that are bright there. It might be hard to see on your slides. They're actually little areas of rock fields that you could traverse across. They're bright because they're not as space weathered, and so they're anomalous for that reason. Next slide, please. And so when I think about what measurements you actually need to do with this mission, I basically listed as basically assess the seismicity, figure out whether or not these are the young moonquake sources currently. image the subsurface somehow, use GPR probably or some other technique that allows you to look at the actual fault geometry, and then bring a camera too, and let's look at some of these rocks, maybe do some geochemistry on the surface of the very freshest exposed material on the moon. So I'll stop there. Thanks.
Fantastic. Thank you.